This conference will now be recorded.
Okay, so if I start with the first question, how many of you are comfortable using priority queue or have ever coded priority queue? I mean, any program which requires built-in priority queue in PQ of STL. Okay, Sai Charan says no. So there are folks who are saying no, they have not used it. So people who are saying no, can I say now stack is something that everyone is comfortable with? Last time we talked about stack. Manish, can you confirm about stack? Because that is something we covered in last class from competitive programming angle. Perfect. So we will be able to build on top of whatever knowledge we have about stack. So if I just open the code for stack that we wrote last time. So people who are new today, people who were not there in previous class, it's just these classes are for, especially for second year, to help them get acquainted with competitive programming. So today I invited some extra people because we are going to start the coding contest from this Sunday, right? So I thought if there is someone else who wants to benefit from these classes, why not invite others? Okay, so stack wise, we said stack, this is how you declare. This is how you get the size of the stack. Then you have push, then you have top, then you have size. And there was an empty function also, right? So stack wise, those were the functions. Can you help me reiterate, people who have used stack, can you help me write start functions in STL? Yeah, guys. What is the first function in stack? In STL, if you are using stack, built-in stack, so it is push. Push requires an element. So any data type, so there will be an element. So that is push function. Usually its return type is void. Then you say we have a pop function. Pop function removes. Then there was one more function to get the topmost element of the stack. Yeah, there was a top function. So here we will say E is actually representing data types. Just E can be any data type. So I'm trying to keep things generic. Okay, so there was a top function in stack. Okay, then yeah, push pop top, there was a size function. This actually returns unsigned int, and there was one more function, two more function in fact, bool empty. Is it empty or not? I think more or less these were the functions that we talked about: size, push, top, and pop. Yeah, so these were the functions. Now you'll be happy to know priority queue also has all these functions, right? So that means functions wise we don't have to learn anything new. So what we have to learn is we have to just learn what is priority queue and how it is different from stack. So I'll say pq code.cpp. So we will just see priority queue. So this is the template we use typically for fast IO. If we are using see in, see out, these two lines I have just kept in the template. So tell me, how do we create priority queue? I'm telling you, it is the way you declare stack. So how do you declare priority queue of ints? Anybody guesses? Similar to stack, the way we create a stack of integers, same way we can create a priority queue. Okay, perfect. So we will say priority queue of int pq, right? So that is the declaration similar to what stack had. Now in this priority queue, I can add some elements. As I said, functions are same: pop, push, size, top. Swap we will ignore right now. Swap and emplace. So push. Let's say we are putting 5 in the priority queue. Then we put 2. Then we put 7. So I'm just, somebody unmuted themselves. Can you keep yourself on mute so that you don't disturb others? Abhinav, we don't need your video. Okay, so we are putting 3 elements in queue, and then we will use other function. We will say pq.size. So this should print the size of the queue. Then we talked about functions like while pq.empty. While this is not true, while priority queue is not empty, then what we will do, we'll keep taking elements out of the priority queue and keep printing it. We'll say pq.top. So this gives the top element. And then we will say pq.pop, right? And in the end, if I print pq.size once again, we will see what size eventually the priority queue will have, right? So can you predict the output of this? Stack wise, we know the output, but stack wise, can you tell me output? If this was stack, the output would have been last in, first out. Is that correct? Now queue wise, let's see what output we will get. Priority queue wise. Yeah. So can you tell me what will be printed here? First thing that we are printing is we are printing size. So size will be 3. Absolutely. That will be in the first line. Then we are doing while PQ is not empty, take the element out. Now the question is, if this was stack, we would have got 7 out because 7 is the last pushed, then 2, then 5. That is what happens with the stack. But this is a priority queue. Priority queue says I will take the highest priority item out. Highest priority in this means, let's say, whatever we have pushed are priorities. High value means high priority. Yeah. So what value will come out? What is the highest value in this thing that we pushed? It is 7, certainly. So first value we will get out is 7. Next value that we will get out will be 5. And next value that we will get out will be 2. The reason they will be in this order is because we are taking them and we are printing them as well. Sorry, we are printing them and we are removing as well. So once you take them out, you will be able to remove them from this. Okay. Once this loop completes, priority queue would have become empty, and here it will print 0. Right. So this is the output that we are expecting. Now, if you ask me in general, what header file is there for priority queue, it is simple queue. So queue and priority queue are both in the same header file. So we don't need to put that because we are including bits stdc++.h. Right. So let's go back, compile the code and run it once again. So this time I said pq, and we will say ampersand a.exe. Let's run this code. Okay, while I made a spelling mistake in while, so it should be while. Let's go back, compile and run again, and this time we see 37520, and that is what exactly is the output that we predicted. Right? So this is priority queue. So hope we understand. Now push function in priority queue is actually log n function, where n is elements in PQ. Right? So this is complexity of push function. In stack, that function was big of function. Pop function, we are removing the highest value. This is also log n. Top function is actually big of 1. If you want to know what is the highest value in your priority queue, you can get to know about it in big of 1 time. So these are the 3 things we should know about it. Size is always big of 1, because size is once remembered and it is returned from there. Empty or not is also big of 1. Right? So keep this in mind, because these things will be helpful to in solving the problems, which are competitive programming problems where we have to bring the time complexity down. So these things keep in mind. Here only difference between stack and this is here push function and pop function are log n functions, and pop always removes the highest value first. Okay. So now we have seen this priority queue. Ideally, this priority queue that we defined, it was priority queue of integers. Now the question I want to ask you is, what if I want to define a PQ of strings? Right? I can go here and modify it to string. So I'm making a priority queue of string now. Here I can go and I can say, let's say apple, banana, and let's say any other fruit, we can put mango. Right? So only thing I changed is the data type here. Priority queue will store string, and this push function became the function which takes a string now. Size function still will return int. Empty function will return true or false. Then top will return as a string, and pop. Now if I run this program, can you tell me what will be the output of this program if we just consider the values? Size and all we don't need now. In which order do you think values will come? Vaishnavi is asking a question. Is its implementation like max heap? That's correct, Vaishnavi. So its implementation is like max heap. Right? So ideally, if I say there are 2 parts of learning priority queue, first part is how to use it. That is what is focus of today. And second part is basically how to build your own priority queue. If you have to implement your own priority queue, which is not the focus for today. Today we want to just master it from the angle of can we use it, how to implement your own priority queue. So today's focus will remain the first point, not the second point. Right? Okay, so here we coded something, priority queue of strings. Just asking what will be the order. So Sandeep, I have just commented out the size part, so we will just see the words that are coming out. So let's go back and this time run the code for pq of strings ampersand a.exe. So I'm compiling and running at the same time. So if you see now, mango is coming first, banana is coming later, then apple. So lexicographically also it is giving, ideally if you compare strings also, we can say, hey, mango in dictionary order is greater than banana. So by default, what it returns to us is it returns in reverse sorted order if you put strings, right? And this is exactly what is called heap sort. You take all the strings, put that in priority queue, you take them out, they will come in the descending order. We will also talk about how do we get alphabetical order. What if we wanted ascending order? But for now, we are talking about default behavior if we define queue like this. Now let me copy this to one more, because that is also important to know, pq of pair.cpp. So in STL, there is a data type called pair. We can create a pair of int comma int or string comma int, anything. Like pair is nothing but it's, you can say it is a built-in structure which has two members. So here I'm putting pair is a built-in structure in C++. It has two fields, and those names, the names of those two fields are first and second, right? So if you get any member of pair, you will be able to access its first and second. So if I say pair of int comma int p, you will be able to say p dot first and p dot second. Treat it like that object, right? So what I want to do is, since I can put any data type here, I'm putting a pair here. Now how do we create pair? We simply create pair with, there is a function called make underscore pair where we give two values and we get a pair out. So I can put pair is 2389, that is first pair I'm putting. I'll put 2-3 more pairs. Let me put 11 and 45, and then we put 86 and then 9, and then let's say 3 and then 8. Now we have put pair in our priority queue and we want to know what is the order in which they will come out. We know output of previous two programs. We wrote the first integral program where we saw the highest value was coming out. Second program that we wrote, we saw mango was coming out first, which was alphabetically greater. Now, if I ask you to guess, according to whatever we have learned, which order will these things come out? In which order will they come out? Based on first element? Yes, there are two possibilities only, right? Either they will be sorted based on the first element, which is the first field, or they will be sorted based on the second field, right? So naturally, it seems like, yeah, first one should be the better choice. By default, if we are not overriding anything, if we are not changing anything, by default, it will sort on the first field. Let's validate that also, because all this will give us learning there. And again, we run it, a.exe. Oh, I made some mistake, it seems. Let me see. Make pair, we have put a priority queue of pair. Let's first compile it, pq of pair, and let's see what compilation errors we are getting. Yeah, this is the problem with STL. It gives so big log that it becomes sometimes hard to scroll and understand what it is saying. It says mismatch type top. Okay, why? Yeah, so got the point. See, top function is erroring out, but because this time it says, hey, top is returning you pair and C out doesn't know how to print a pair. So what we will do, we will take it in a pair variable, pair of int comma int, and we will say current pair is equal to top. So top will give us the pair, and when we are printing the pair, we will say current pair dot first, and we can do with space, we can do current pair dot second, right? So we are printing first and second, first and second. That's how the output will come. So I believe that was the only issue. Yeah. So see, one issue and such a big log. So let's go and run this now. And what we see is they are coming on sorted order, reverse sorted order of first field, right? Now my simple question to you is, what if we want to sort on the second field? We want this output, but it should be sorted on the second field. Anyone, any thoughts? By hook or crook, we want that output. Okay, so Nagasai says you should use compare function. Yes, but Nagasai, yeah, we will come to that syntax. But my question is, by hook or crook? What is the easiest way to get that output? Let's be lazy, let's be crazy. Awesome. So Ishwar says replace first with second. So basically, if we swap their order when we were inserting in the pair, then we will get the reverse sorted. Is that true? Because then what we are doing is we are essentially making second field as first field, right? But the challenge is our output will come in this order, but we want output should be 89, 45, 9, and 8, right? So Koteshwar Rao is saying that we should run it while loop reverse. But what is reverse here? Priority queue loop is not index based. Okay, awesome. So Nagasai says, see, you can swap the pairs here, but at the time of printing, you can swap them also. Print first, later, second, first. So ideally, you want the sequence this way, but 89 output that we are expecting is we are expecting output in a way. Output should actually be 9, sorry, 86, 9, then 38 should be above it. Sorry, 38 should be below it because we are sorting based on the second field now. 38, then third should be 45, 11, 45, and fourth should be 2389. So we wanted output which is sorted based on second field, and in order to sort based on second field, the laziest way we are saying is at the time of insertion just reverse them, right? If we reverse them at the time of printing, also reverse them so that you get the correct output, right? But that is kind of, I mean, holding your ear by rotating your arm, right? So it is okay. So Praneeth is asking one question: is there any way which we will make the priority queue work based on second element? Yes, Praneeth, there is a way. We will come to that. Yes, there is certainly a way. We will talk about that. But right now we are just getting comfortable with the priority queue syntax, because once we know these things, it makes our life so simple when we are solving some of the tough problems, which kind of usually we feel like are solvable with high time complexity. So priority queue has good set of problems, and good news is there are fixed set of problems or fixed set of patterns to which you can apply it. Okay. Yeah. So now coming to the syntax where you asked, I want a custom priority queue. When I say custom priority queue, let's go back to int once again, because once we are able to develop the skill with int, applying it to other category of elements will not be a big deal. So I'm putting the same int priority queue code in a new file, and I'll call it pq custom logic. Okay, why I say custom logic, I'll tell you. Let's say if I put 3 elements in priority queue, 20 and 7987. Can you tell me what output we will get right now? If this is our code, what is the output we are going to get right now? By default, it gives elements in which order? Yeah, it gives highest first, then second highest, then third highest. Right? That is what we learned by a previous experiment. So let's do that same thing here also. If I go and do G++, so I'm a negative, y 0? 0 will not come, right? So what is the name to the file that I gave? PQ custom logic. Yeah. First I'll go with PQ custom logic, compile it, got compiled, run it. So this is what we saw. Oh, 0 is also coming. What did I? Oh yeah, sorry. I do not want these lines to trouble us now. Once we have seen them, you are right, Koteshwar. This will come. So yeah. So in this output will be reverse order. That is what we know we will get. So first question is, what if I simply want them in reverse order? So see, the syntax is pretty simple. For that also, you just need to remember the syntax. You don't have to code anything. It is like you can put a vector of int here and then comma. Third thing you have to put is you have to put greater of int here. This is a complicated syntax. Let's do a quick revision of what it is. So priority queue has a built-in priority queue has a syntax that we will have to remember if you want to make your life simple, and that is priority queue with min first. So when we say min first, it is like min heap. There is another name also for priority queue, heap. So when you are using minimum value comes out, you will say it is min heap or min priority queue. Otherwise, you will say max heap, max priority queue. So this syntax is, earlier syntax was here it was priority queue, p will be small, priority underscore queue, and then you were saying data type, and then you will say pq. This was the old syntax. Now, whenever you want the reverse order, just reverse order, then you just have to change the declaration. Rest all will remain the same. The declaration will become priority queue. Whatever data type you have to put that one. Second parameter is fixed, and you must keep it same way. It should be vector of that data type. Vector of that particular data type. And third parameter should be greater of that data type. So greater is a built-in comparator. This priority queue will be, I'll call it min pq. So that it tells us that minimum element will come out now, right? So same syntax, just see it once. This is fixed data type, vector of data type, greater of data type. Now you may ask, if greater is there, is lesser also there? Answer to that is yes. Lesser is another name for whatever default declaration we gave. So that's why we don't need lesser. This is for the default behavior, right? Now we are going and trying greater. What will happen if I go here and if I just put vector of int, greater of int? Now if I run my program, what happened? Previous declaration. Okay, I think two declarations came. So I just wanted to comment previous and leave the next one. Otherwise, I'm redeclaring same variable. And let's run. So this time you see minimum element comes out first, then maximum, then higher than that. Now you may be wondering to ask, hey, will this syntax work for strings also? Let's go and look at our string code we had written. So we come back here and we say, okay, if we want strings in lexicographically increasing order, can somebody tell what should I write now? What should I write here? For strings, it is just a revision of syntax that we are doing. Can you tell me? How do I declare priority queue for strings? Yeah, it should be vector of string. Perfect. Vector of string. And third parameter should be greater of string. Right? Yeah, so Koteshwar was asking a question, is it a function here? Answer to that is no. When you write greater, you can just write greater and the data type. Okay, there is one more question from Shaktik. Shaktik is asking, will min queue affect the time complexity? Answer to that is no, Shaktik. So all these functions, be it min priority queue, complexities are same for min PQ or max PQ, right? So they will not change. Now also insertion will be log n and removal will also be log n. Right, let's come back here. So we just changed the syntax and you see the magic will happen now. G++, it was PQ string ampersand a.exe, and just see now we are getting in this order. And this is where people see, like, when you participate in a contest, what happens in initial 10 minutes itself, somebody solve the problem quickly, right? You feel like, hey, that problem was very hard for me. I don't know how people are solving so fast. The only difference between those people and you is this, that they know all these tips and tricks. If somebody gives, hey, given strings, I've seen that happening, given some strings, you have to sort them in alphabetically increasing order. So what people start doing, they start writing their bubble sort from scratch. And people who already know these things, Bhavish, you don't need to stream your video. Yeah, so people who are aware of these things, for them, it is just writing priority queue, pushing the elements by reading from console and printing them back, right? So this improves your speed. That is where STL is really helpful to people who participate in contests. Okay, so we have seen this in uh, strings. Now, if we move same thing back to pair, now this is where the syntax will start becoming complicated. Now tell me, how do I make it in priority queue? What should I write? Yeah, guys, go ahead, help me. Initially, it looks scary, but once we get comfortable, things change. So we say vector and pair of int comma int. Perfect. So that becomes a vector. Now you see the matching becomes a challenge. We have to match everything. And third thing is greater and pair of int comma int. So it is becoming an unmanageable, but truth is only thing that is replacing is our data type, which is becoming pair. Everywhere, if you see the highlighted portion, if you see, it is priority queue of data type, vector of data type, greater of data type. Right? And if we do this, now what we will see, it will still be sorted on the first field, but it will start sorting them on increasing order of first field. So PQ of pair and then ampersand a.exe. Okay, what mistake did I do? PQ was not declared. Okay, let's see. Line number 16 has a problem. Template argument 3 is invalid. So I made some mistake in writing the syntax. Okay, so here actually if you see graters, curly bracket start, curly bracket closed. Pairs started and closed, but there is no closing for the initially angle bracket. Sorry, this angle bracket is not having a closing angle because this closing is for greater, this closing is for pair. So I'm missing out on one. I'll tell you a tip so that we can avoid such compilation mistakes also and we can code faster. Let's compile and see. Now it is sorted on the first field, but this is sorted on ascending order, right? So how do we get around this problem that, hey, we don't want to write such syntax again and again, it is becoming confusing. So what people do, people use a concept called type def. Type def is another name for a given type. So pair of int is a built-in type. You want to define another name for this, you can call it PII. People use this syntax. So this PII is a short form. Ideally, you can choose any name. It's not necessary you use PII, but PII is a short name for pair of intent. So now if you see in declaration, we can avoid those angle brackets. This makes our life really simple. See. And in fact, this PII we can use here also, wherever we were writing pair of intent. Right? So this will also work if we go and see now. See, nothing changes in execution, but code-wise, it becomes more manageable. We have type less and we can code faster. Now you may say, hey, when we are able to do type for pair of intent, can we do type def of this vector also? Why not? Let's do type def of vector of pair of intent to VPII. That is also what people do. So this means vector of pair of int. So this syntax will also work. And this is where you see cryptic code from a lot of well-versed programmers. Right, so you can use these short names. Okay. Joshua is asking one question: creating own names to simplify solving. Yeah, Joshua, people use this to give own names to any existing data type so that when they are solving the problem or coding, they can code faster. Right, so this is the shorter syntax. Perfect. Okay, so now we understand the priority queue and the ascending order, descending order, which people call as natural order or unnatural order. Right, so natural and reverse natural. So we know natural order for numbers is ascending, but priority queue treat natural order as high value, high priority. This is what the default behavior was. If you want to change that, we talked about, we used a comparator for data type. This is what we started using. It will give us the natural order. So this we understand. One last thing that we need to understand about priority queue is, let me say, what if we want a custom logic? Now, what do we mean by custom logic? Let me give you a problem statement here. Given few numbers, get them in order of number of digits in them. More digits, more priority. So if I give you numbers like 3, 1, 4, 5, 2, then 34, then 0, then 23. If two numbers have same digit, then put higher number first. So according to these 3 lines that I have defined, can you tell me what is the expected output for this? What output are we expecting for this? What will be the first number that will be printed first? What is the highest priority number in this? Out of these numbers, given few numbers, you have to get them in order. Okay, so 1, 4, 5, 2. This has highest number of digits, so this should come first. Then the second highest number of digits are 34 and 23. We said if two numbers have same digit count, then put the higher first. 34 will come first, then 23. Then 3 and 0 are single digit number, put 3 here, put 0 here, right? So because higher number we want first. So if this is the ordering we want, obviously we cannot use the built-in lesser or greater, and there is no other function which is built in which we can use to get this ordering. So that is what brings us down to this concept of what if we want custom ordering for ourselves. If we want custom ordering, the thing that will change in this is this comparator you will replace with your own comparator. And that syntax is just put a comparator here, CMP. Right. So what I have changed is I have changed greater, and this comparator I'll make sure I do not write generic. I'll write in such a way that it will take 2 integers. So we are writing a comparator. This is a function name. Oh, sorry, this is a class name. So in Java, we will define a class CMP. This class should have a public function which actually overrides. So this is a little bit of CPP, but trust me, once you practice it 2-3 times, this syntax will start becoming clear to you. Many times I keep forgetting the syntax, and I keep referring back to the documentation and see that what should we, how we should write it. So I always keep forgetting whether the function return type is bool or it is int. So for now, let me go with int. It is an operator. Even I'll have to look for the syntax. Let me quickly do that. So priority queue, C++, custom logic. Right, so let's search for that. And I'm sure Geeks for Geeks will come first to give that answer. Priority queue for structure or class, order by first. Let's see. So here I am to just see the syntax for, yeah, so this is the syntax. Ideally, it can be class or it can be structure. So you have to give the same name that we wrote here. Then you will operator. So you are actually defining an operator to compare two things. So operator, 2 round brackets. Then we are comparing int A and int B. So these ints are because we are passing integers. Right? So that is what this function should take. Now this function should return. If this returns true, then who will have higher priority, A or B? I think if this returns true, we will have high priority. That is how it is. So we will first write it, then we will learn it. Right? So can you tell me how do I get number of digits in A? How many digits A has? How can I get? Yeah. So most of the time we write a while loop, we calculate, right? So let's see the shortcut. Digit count in A. So digits of A will be equal to. There is a simple formula we can apply. Think about it. If the number is 1000, can you tell me how many digits it has? 1000 has how many digits? It has 4, right? Can I say 1000 is nothing but 10 to the power 4? If I take log base 10, then what will be this value? This value will be 4, obviously, right? But if I take a number 1050 and then I take log base 10, now 1050 will certainly be 10 to the power 4 point something. There is something in points also. But we are interested in integral power. We are not interested in this, right? But log function will always return us a decimal number because the return type of log function is double. So what I will do, I will call log 10. Log 10 is a built-in function. Log 10 of A, that is what I will call. and I do not want the decimal part of it. So can I use a function floor? So floor will get rid of those decimal variables, and I add 1 to it. Sorry, one mistake I did. 1000 is not 10 power 4, it is 10 power 3. I was doing a mistake in speaking that. It should be 10 power 3. So 3 will come, so we have to add 1 to it. It will become 4 then. Like 1000 is 10 power 3, but number of digits are 4, so we will add 1 extra, and we are taking floor to get rid of the decimal point. So this is a shortcut way, one line code, which most of the competitive programming folks would know. One line code to calculate number of digits in a number. So digits of B we will calculate like this. Now be aware of one thing, that is what will be corner test cases also. Log of 0 is not defined. So if A is 0 or B is 0, that log is not defined, and we should not even be calling this function. So let's take by default dA as 1, and we say if A is not equal to 0, digits of A is equal to. Now we add this part. Otherwise, dA will stay 1. If number is 0, number of digits is 1. Same way we do the thing for dB also. dB by default assume it is 1, and if B is not equal to 0, its digit count will be, dB will be 1. We have already taken, so plus is equal to this. So we got number of digits in A, number of digits in B, and most of the times this function that we are writing, this function will return bool. By default, you can try returning a dA less than dB. So what we are returning, if we are returning false, here if we are returning true, if number of digits in A is less, then there is some ordering defined, which again I don't know. So I'll just experiment and figure out. Less than produces which kind of priority queue, and greater than puts which kind of priority queue. Yes, he is asking what is log of 1. Yes, Sandeep, log of 1 is 0, because when you say log of 1, you can always say it log of, if you imagine if it is base 10, so you can always say log of 10 and 10 to the power 0. So 0 comes forward, this becomes 1, 0 into 1 becomes 1. So log of 1 is defined, but log of 0 is not defined. Make sense, Sandeep? Okay, perfect. So let's see now. Now this logic that we have written, this is taking this into consideration. Okay, Sandeep is asking if digit is 1. Yeah, if digit is 1, what will this return, Sandeep? Floor of 0. So floor of 0 will be 0, and that 1 we have already included, isn't it? Is that making sense, Sandeep? Yeah, for 1, this will work perfectly fine. Okay, so now we have just changed, we have given a different comparator. This complicated syntax of comparator we have to remember. And now if I go with custom logic priority queue, G++ PQ custom logic ampersand A. Okay, did I miss anything? Expected semicolon after class definition. Yeah, that is another peculiar thing C++ requires. Any structure or class should end with a semicolon. So now if you see, we are sorting them based on their digit count. The highest digit first, second highest digit second, third highest third. So if you return A less than B, then still it is a max heap. So this is the max heap. If you want max heap, you will put A less than B, where A is the first parameter, B is second. And let me reverse this logic. Now we get min heap. And now the custom logic that we were defining, we were saying, let's take this. If these were our numbers, then we will. So I'm putting this as the first number. Tweak our custom logic. Will help as the second number. Do that. This as third number. 0 is 450. And these are and to jumble them in numbers, but I we are if we want. See what logic? We have two conditions to include. These are our numbers, not incorporate. If higher digits, no doubt, we should send directly. So higher number we want first. So of B digits are greater than digit A, we will return true. Can I say that? We can directly return greater than digits of A, return true. Is that correct logic? Higher number digit will come first. Logic was this. If digits of A are less, return. Agree? If digits are different, so this compare the digit. So value first. You guys make sense? Okay. Of whatever we talk. How do we put priority or custom out here? So just the priority. We will say the comparator and PQ. This is how. Now the key question is define this comparator. We will have we will have a class CMP here. The function name will be B and second parameter of B. If you return A, if you make it A. So this is the syntax that gradually you need to get used to. This will help you create priority queues with any data type or with custom logic. Hey guys, things are making sense? Any questions from anyone? Okay. So syntax is something that will take some time for you to grasp, but let's see the applications, what kind of problems it helps us solve, and how easy this will make the problem for us. Right. So let's see the first question. Kind of problems where you can apply priority queue. Shaktik is asking a question. Can we use function instead of class? Yeah, Shaktik, there is one more way also where you can just define a function. Yeah, that is also possible. You just give a function and you can use that. But I prefer using the syntax define a class. But yeah, there are certainly easy ways also to do things. Right? But one change comes is if you use a function, then I think you will have to put 2 round brackets here. I think that is what somebody was pointing out. What Ishwara was saying. Let's try that in case you really want to do that. I'm just copying the same function outside, and let's put this function here, and let me change the name of the function. Function will be bool cmp1. So now it is a function. It is no more operator overloading. So we have defined cmp1 function, and our goal is to try whether this function syntax will work or not. So when you use function, you have to give round brackets. So let's go ahead and do. Okay, so it was changed. I'm not sure, but yeah, there is certainly a syntax which I typically do not use, and I'm not even sure. But yeah, you can search online, you will find that one. Functions are possible. So let me revert it back to CMP. So now this works. Okay, so now we have got this. Let's take a look at kind of problems and pattern of problems that it helps us solve. There are some problems you will find kth largest element in an array. Simple cases we solve is first highest. Okay, maximum element in the array we know how to solve. We know second max element in the array. We can easily solve. Both of them will work in linear time. But what if we want in declaration we cannot give function sir? Okay, Nagasa is saying in declaration we cannot give function. Nagasa, I do remember there is some syntax, but I just to save time I do not want to run for that. But there is a syntax where you can give directly function also. Right? So if required, I'll send that in a group in your group, another template for this. Yeah. For now, we will move forward. There is function syntax also certainly. Let's come back to our question. Question is find kth largest element in the array. And I'm hearing a response, can we sort the array and find the kth element? Okay, so one approach that somebody is suggesting, that Koteshwar Rao is suggesting, is approach 1. He says sort the array and then sort the array in ascending order, let me say. Then highest element will be where? Which index will have highest element? First highest element. At which index will be first highest? Yeah, it will be n-1. Second highest, it will be at n-2. Right? Where will be kth highest? At n minus. Shouldn't it be n minus k? Why n minus k minus 1? N minus k, right? Yeah. Okay. Sirisha is suggesting something. She says insert elements in the priority queue and keep popping the element. Wow, that gives another approach. So what she says is let's not sort the entire array. Why? Because if we sort the entire array, what will be the time complexity? What is the time complexity of sorting? N log n. And after that, finding kth element will take how much time complexity? Once you have sorted the array, how much is the time complexity of accessing n minus kth index? It is 1. So overall complexity becomes n log n, and space complexity is big of 1, because built-in sort function, if you use, we do not require extra space. So this is what our first approach is. Second approach, let's go with a suggestion that Sirisha is giving. She's saying declare PQ. Which kind of PQ we would take, Sirisha, according to this problem? You want to find kth largest element. Min heap, max heap. You need to suggest us so that let's see. Okay, so she says max heap. Why max heap? Because when we take the first element out of the heap, it will be the maximum value, then second max, then third max. So she will keep popping all the elements until k elements come out. So kth element that comes out of PQ will be the answer. Right. So this step is first. Then put all elements of array in heap, in max heap. Now keep taking out elements one by one. We are suggesting kth element that comes out will be kth largest. Do we all agree that this approach will work? Right. Perfect. So yeah, this approach will work certainly. What will be the time complexity of this approach? So one element coming out, time complexity is log n. If n elements are there in the priority queue, pop operation has log n time complexity. Checking has big of 1. We are removing, first we are putting all the elements, log n time complexity. Then we are removing one by one. Complexity will be higher. Can we say it will be total n log n? Do you agree? N log n, because every element insertion is log n, and deletion one by one we are doing for n elements. This will be log n. So total n into log n. Space complexity, can you tell me? In approach 2, it is big O of n. Why n? Because now we have started using a heap, right? So there is extra space complexity and there is extra time complexity. Now, you know what we want to reach to is, we want to reach to another approach, and that is what is the beauty of priority queue. We want time complexity of n log k. We don't want n log n. We want n log k, and this will certainly be better than n log n. So Joshua, we cannot reach to order of n here. So we can reach to n log k if it is a generic problem. But yeah, if you say first highest element, second highest element, third highest element, then you can solve it in kind of big O of n. Third highest also can be done in big O of n. But if k is changing dynamically, and imagine total array size, if it is 10 to the power 6, then k can be anything. K can be 10 to the power 6 also. You cannot take n to the power 6 variables like we do in max, second max, or third max, right? So generic case, if we have to solve, this is best we can reach to. And now with priority queue, we have to think, how do we apply priority queue to solve this problem? Once you solve this pattern, you will see like there are 4 or 5 problems that we can form on this pattern itself. Okay, so Goteshwar Rao is suggesting something. He says, run a while loop until count reaches to k. But can you suggest what are we doing as the first step? If this is the time complexity we want, earlier approach told that declare a priority queue, put all the elements, and then do something. So what is your approach? Can you throw some more light on your approach? Yeah, Goteshwar Rao, can you explain? Okay, creating a priority queue. What kind of priority queue? Declare a PQ. What kind of PQ you want? Max heap, min heap. Okay, max heap. Let's go with your approach. So you are taking a max heap. Then you are suggesting run, put k elements in this. Is that correct understanding? Put first k elements into the max heap. Okay, so let's say put first k elements in max heap. Then what should we do after that? After that, we want kth largest element in the array. So what should we do? Yeah, guys, let's try to understand the simulation here. Let's say if the array is there 9, 2, 6, 4, 5, 0. Can you tell me what is the first highest element here in this array that you are seeing? What is the first highest element? It is 9. So this is the first highest element. What is second highest element? It is 7. This is second ranker. What is third highest in this? Third highest is 6. Okay. So imagine we are looking for third highest element. So for element, what approach he was suggesting is, he was saying take a max heap, and in max heap put first 3 elements. So let's take a max heap now. If we take a max highest element on top, so take a max heap, put first k elements in the max heap, and that is where we are proceeding from. Now if we go to the next element, it's 7. What should we do at 7? So the hint I'll give you, what we are trying to do is, we want to make sure here, keep one thing in mind, we will not let heap increase beyond y in size, beyond k in size. Okay, so we will keep heap size to k. Then only we can reach log k. Because if heap size is n, insertion deletion capacity become log n. Okay, so now Koteshwara says something. So he says when we have come here, when we have come to 7, he says delete highest element. That is what he's saying. But Koteshwara, you may be wrong here. Why? Let me put it this way, that let's swap their order. Let's put 6 here, 7 here, 9 here, and 4 here. So see, what you are suggesting is you are suggesting me to delete the highest elements. Initial 3 elements, highest will be 6, then 4, then 2. Now the moment you reach to 7, if we delete 6, we will lose our value. That will be bad. We do not want to increase the size of heap more than 3. So we should delete the least element. That is what you are suggesting. Yes, do you get it? Since we have to keep track of 3 highest values, he's saying it is better to delete the least value that is of no use if 7 can come into picture, because one among these 3 will be the third highest. Is this true that we should delete the least value, not the highest value? Right? If we have to delete the least value, max heap is not the right candidate. Max heap can delete the max value, but not the least value. So which heap should we take? Will it be max heap or min heap? Yes, it should be min heap. So keep in mind, whenever you are finding kth highest value, you will take min heap. Whenever you are finding kth smallest value, you will take max heap. So it is reversed. And we saw that we have hit a roadblocker earlier when we were going with max heap. Let's change it to min heap and see, can we keep track of highest 3 values? So I'm going with this array once again, with this modified array in fact. So now k is 3. Let's continue our thing with min heap this time. So first element put in the min heap, second put in the min heap, third put in the min heap. So you have 2, 4, 6. That is what your min heap looks like right now. When you get 7, compare 7 with the least value, and you can get least value in big of 1 time. Comparison tells you 7 is bigger than 2. So my question to you is can 2 be in top 3 elements if 7 is the next element? 2 doesn't deserve to be in top 3 elements, right? Because 7 can be that another element, right? So obviously we will say, let's get rid of the least element that is of no use for us based on the problem we are solving. We bring in 7, and because this is a min heap, it will readjust itself. The ordering will become 4 will come on top, then 6, then 7, because min heap will maintain that order somehow internally, which we will learn in future how we develop our own min heap, how it is readjusting in still log n time or log k time, right? Now 7 came into picture, we have taken in. Now when 9 comes, we say 9 is greater than 4, get rid of 4, put 9 in. So 4 goes away. When 9 comes in, it will become, your heap will readjust to make it 6, 7, 9. Now you take 5 in. If you 5 comes in, 5 will say, I am smaller than the least element. So does 5 deserve to be in the top 3? Absolutely. So answer to that is no. Because when we see 5, when current value is less than even the minimum value we have so far, we say discard it, don't put in the heap. 0 comes, 0 is less than 6, don't put it. So what you get in the end, the heap that you get in the end, it has top k values, right? So who will be the third highest? Who will be the kth highest once you have this heap? Where will that be located? It will be on top of heap, right? So we just get the top and we give the answer, right? So that's the beauty of this. So let's say declare a min heap, put first k elements in the min heap now, and then you say for every element e in array after kth index, what you do if e is less than heap dot top, what should we do? Tell me. We are just writing algorithm, the steps that we saw, we're trying to visualize them now. If the next element is less than top of the heap, then what should we do? We should pop. No. See, Shaktik, 5 was less than 6. Did we pop 6? This is next element in the array which is lesser than the top of the heap. Then don't do anything. Keep this in mind. If next element is less than this, we don't do anything. What if next element is greater than this? If it is equal to, then also we will not do anything. Right? So if it is greater than, then we should say heap dot pop, remove the top element, and then we say heap dot push current element. right? So this is how we will continue, and in the end we will say our answer is heap. So we get the answer like this. And what we change from the previous approach we were putting everything in the heap. Now we are making sure heap should contain only k elements at a time. Since the size of heap is never going beyond k, we say time complexity we have reduced to n log k. This makes sense? This is one of the problem where we can apply heap straight away. This problem gets asked in 4 variations, and I believe like you will be able to apply this pattern to all 4. Find kth largest, we did. Find kth smallest, you can do. Find k largest elements in the array. So this time you are not asking for one value, you are saying top 3 elements. Find top k elements in the array. And same way if I ask you, find least k elements in the array. All these 4 problems are simple implementation of heap. We can use min and max. In this case, we just printed top. If the problem is print top k elements, we will write the while loop. We'll keep taking out one by one and we can print all of them. So straight away application is this. Right. Okay, so can it pass when my given quotation multiple will be multiple mean is like first find third highest, then second highest, like that you're asking? Then yes. Yeah, when queries are there, let me see if it's saying given an array. Okay, then what we will do, we will basically answer, because then one time just sort it and keep answering queries. So this will be kind of a pre-processing problem rather than heap problem, right? Yeah, so if this was the problem, we will do it this way. Now let me give you one problem for this thought process. It will not be straightforward heap problem. Given an array A of size n, given another value x, find k nearest values to x. Given another value x and integer k, right? Let's see the problem. The problem is find k nearest values of a given value. So if I give you an array will be, let's say 5, 8, 9, 12. It is not essential that array is sorted, but if I give you these values, if I ask you, my x is 15 and my k is 3. What are the 3 nearest values of 15? Which are nearer to 15? It can be on left side or right side of the x-axis. If 15 is here, what will be the nearest points to 15? Think of it that way. Okay, so I'm hearing from Abhishek that answer will be 12, 9, and 8 in any order right now we can say. So are they the nearest? 15 is nearest to 12 because the difference is just 3. 15 is nearest to 9, certainly, to 8. What is the difference of 8 from 15? It is just 7, and 34 has higher difference, right? So if you have to solve this problem, nearest values, and we want to do it in n log k time, not more than that. Because sorting and searching, you can solve this problem in n log n. N log n will be easy. Okay, Sirisha is suggesting something. She says create a min heap. Okay, Sirisha, we take a min heap, then let's see your approach and then we will debate if it works or not. Take a min heap. Okay, then you are saying Okay, Shoktik is also giving an approach. Shoktik says create a heap, loop over the array, and put in heap. What are you putting in the heap, Shoktik? You are putting absolute value of x minus a of I. And you are maintaining heap of size and keep its size fixed to k. Is that what you are saying? Yeah, so Sirisha, you are saying push the difference, but difference also you should put absolute difference. Why? Because 12 is this side of 15, 12 is left side of 15. So difference between 15 and 12 is 3, right? So you should take absolute value, because if 16 was there, 16 when you push in the heap, ideally you should be putting absolute value of 1. That this is distance 1 away, this is distance 3 away. So one distance away guys should come first. So that should be our priority. So here priority order is the difference, right? So you are saying you will push the values in the min heap. Let's see. Okay, let me change it to 16 and 34 here so that we see the values on both sides. Now what answer change will happen? What will be the answer? Nearest three values of 15. 9, 12, 16. Can I say 8 goes out now? Yes. Okay. So if we see this way now, you are suggesting me to take a min heap. Let's take a min heap. Now in min heap, what are you putting? You are putting first k values. No, every value is difference. You take 5 and 15 is difference. The difference will come out to be 10. Then you take 8 and 10 difference. We are taking absolute difference. 8 and 8 and 15 difference will come out to be 7. Then you take 9 and 15 difference, it comes out to be 6. So you have three values, your min heap is ready, and min heap is sorting in this order, right? Now when you take 12, what will you get as difference? You will get 3. Now whether to keep 3, what will be kicked out? If 3 is what you want to keep in, what will go out? 10 should go out, but you have taken a min heap. Min heap will remove 6, not 10. So what should we have taken? Min heap or max heap? Yes. So we are trying to find, we should be taking max heap. Why? Because we are trying to find elements whose difference is least. So we are trying to find least three values, right? So keep in mind, when you are finding least values, you will take max heap. Okay, so let's go with max heap now. So with max heap, you say when 5 comes, you will be putting difference of 5 will be 10. Then difference of 7, difference of 9 will be 6. Max heap will be, sorry, reverse. I'm drawing it in the wrong way. Let me draw it here. So our values of array and all we are taking here. Let me paste that here. So our array came, our x came, our k came. So now let me draw the max heap. So max heap made the first difference is 10, goes on top. Then the difference with 8 is 7, different with 9 is 6. Now you get 12. The difference of 15 and 12 is 3. So you will be putting 3. You will remove this because size has become equal to k. So you are bringing 3 in. And when you bring 3 in, 3 will go down because this is max heap, right? 763. Now when 16 comes, you will put 1 in, you will get 7 out. So 1 comes here. So this is your max heap. When 34 comes, you will ignore 34 because 15 minus 34 mod is 19, which is more. We don't want that in. So we say three highest values are this. But now the question is, you were supposed to give those values. You are just having difference in the heap. How do you get those values? You are still not able to get the answer, the final values answer. Answer was not 631. Look at this. The answer was 9, 12, and 16, not 631. So what do we do? How do we get that answer? Awesome. Awesome, RK. So what we should do in heap, when you had put 1, put pair now. In pair, what will you put? Along with 1, whoever gave the difference of 1, that value will be there, 16. So this is the heap you are going to use. You will use heap of is signifying the difference, absolute difference, and second is saying the array value. You can store array value or anything. You can heap or stack or queue. Prefer putting indices. Don't put the values, because once index is there, value you can anyways get. Many problems just require the index to be printed. So this will help you solve both the problems. Right. So we take a max heap, but this time we take heap of pair. And because we are taking it of pair, that will help us reach to the answer. And now you will realize whatever we discussed, why we discussed about heap of pair, why we discussed heap of string. Right. Okay, one last question and then we will end this session. Just to think, given few strings, or let's say given a paragraph. So paragraph, when it is given, it is a big string multiplying the string. In programming, it will be kind of same. Given some paragraph, find case occurring. This is the word problem. Most we want to solve. Okay, most occurring words, the words which appear most number of times. So this is a problem that is used by crawlers to parse the web pages. So this is a good line to see and read for everyone, as this makes people learn. So what is the highest occurring word? If I ask you, give me two highest occurring words in this sentence. This is occurring 2 times. Is it occurring? Okay, this is not a separate word. Is work 1 time. A is not a separate word. Okay, I'm searching. Let me fix the boundaries also. And now it will search only once. Yeah. Good is occurring only once. Line is occurring only once. In this we don't have. This is okay, and this is the first most occurring word. Let me make it unique so that one word occurs 4 times, and let me insert few random words. So we are kind of creating test cases for this problem. Now tell me what will be the answers. What are the 2 most occurring words? Okay, Vaishnavi, I will come to your question. Good that you are asking that question in previous thing. Yeah, guys. So C is occurring 3 times, obviously. And how many times is this occurring now? This is occurring 4 times. So your answer should be this and C. This is occurring 4 times and C is occurring 3 times. So now question is, how will you solve this problem? And always keep in mind, whenever you have these problems, one question should always ring in your head. If C was also 4 times and line was also 4 times, then there are 3 words which are occurring most times. So in such problems, problem statement in online contest will give some constraint. If there are 3 words or more than k words that meet the criteria, then give us the lexicographical sorted list. So there will be some distinction given for sure, based on which you can refine the custom logic of your heap, the comparison logic. Right. For now, I'm making the constraints relaxed. I'm saying if there is a word, the 2 most occurring word, I can put a constraint that none of the word will have same frequency. If I put a constraint like that, then let's see how do we apply heap to this. Perfect. So Praneeth is saying, can we use map? Yes, Praneeth, you can use map. You will go over all the words and you will build a map of each word and its frequency. So you will first reach to that point. Yes, certainly. After you got a map, what will you do? How will you find the most occurring words? Because when you are building map, that time you cannot keep track of it because frequency for every word is changing. But yeah, you can keep track that time also. But you can keep track of what is the first highest, second highest. But when k is more, when k is 20 or k is 30, then you will require some processing afterwards. So imagine map you have built. You can go over this string, this entire line. For every word, we can count the frequency and build a map. This we are clear, right? build a map for every word frequency. Once we have got there, what should we do? Awesome. Then we can put it in heap. Put in a heap. What kind of heap? Now tell me, this time don't make mistakes. Tell in one go, max heap, wrong. We are finding maximum occurring words. We are finding highest values. When we find k highest values, we use min heap. Right? So keep that in mind, because this confusion keeps coming, and that is what we'll go with the exercise link that I'll give you. So we'll use min heap, and sorting parameter in min heap will be our frequency. Can I say create a min heap with pair and put int frequency for this with this? Yeah, peak. Our thing that you will put is pair of intent, a pair of int string. Then you will say vector of pair of int comma string, and then for min heap we discussed we'll use creator pair of int comma string. This priority queue, if you use by default, the first three things that it will give you out, they will be your most occurring words, and you can restrict this heap to never exceed size of k. Put first k values from map, and then after putting first k values, iterate over every other value and then start putting. But map will not give you a fixed order. So what essentially you can do in order to avoid any other situation, iterate over entire map, put everything in the queue, right? Everything in the priority queue. Then if you are putting everything in priority queue, then you can take max heap, because then top two values you are interested in, or top k values you are interested in, right? So this would give you a fair idea of what priority queue is and what kind of problems it solves. So most of the priority queue problems will require k highest and k smallest values, or k nearest values. This is something that will be there in the problem statement, and such problems you can easily solve with n log k. That's the crux of today's discussion. So in between, Vaishnavi asked a question. I think it was Vaishnavi who raised that question. Let me go back. Yeah. So Vaishnavi was asking a question: what if absolute value of two things is same? So yeah, Vaishnavi, in priority queue, you can put duplicate values also. Then you will use your custom logic. So if two keys or if two values in the priority queue are equal, you can still sort it. So imagine if priority queue is max heap, two values get 9 and 7, 5. So this is your max heap with 4 values. Their order will be defined based on your custom logic. So if you want to handle it, you remember we discussed the problem where we said if two numbers have equal number of digits, then our logic should change. But otherwise, both of them will be on top in max heap if two highest values are there. So priority queue allows you to put values. Does that answer your question, Vaishnavi?
This conference will now be recorded.
Yeah, sure, RK, I'll do that. So we were talking about how to declare max priority queue, how to declare min priority queue. Third thing we should know is how to define custom logic for PQ ordering. So that was the third thing. These three things, if you get comfortable with, you will find it extremely easy to solve problems that require heaps. Right? There is one more standard problem on heap that I have not discussed with you, and that is considered to be a very good problem on heap, a frequent interview question also, but that I have put up in a contest. I'm going to share a contest with 3 problems which require heap application. So feel free to try them with heap and see. They are not the questions I discussed with you. Right? So they are kind of a practice for you so that you can see that can you apply heap, and when you apply heap, can you solve those problems with a better time complexity. Right? So sorting is needed. In this case, another category of problem you feel like sorting is need, but you don't need to sort entire array. So this is again capturing the pattern of problems of heap. So this should help you these things, and heaps make your life simple. Right. So with that, we will end it here. And yeah, okay, I'll send the notes of priority queue and the previous class that we did on stack. Both notes I'll make available to you. Okay, guys. I hope you enjoyed this session. You got to learn something new. So yeah, we'll keep doing sessions like this, which help you improve your efficiency, speed in the contest. So what I'll share with you is this. Is one is notes, second is link to the contest, where you can practice heap problems. Okay, so Vaishnavi is asking, could you define custom logic related video for better understanding? Yeah, Vaishnavi, I'll try to share this video with all of you guys. So custom logic you can watch at a lesser speed, and still if you get stuck, if you have any questions, feel free to send your message in the WhatsApp. Intent of these sessions is to help those people who are interested, who are committed for coding, but they lack this direction, these tips and tricks. So that is why we are doing some of these extra sessions for you guys. Right? Yeah. So this video should suffice, Vaishnavi. If it doesn't, still let me know. Okay. 4H5, can you send stack video also? Sure. I did not even check stack video if it is ready. Yeah, I'll check. If stack is also ready, I'll send you stack as well as priority queue both. Okay, thank you guys. Enjoy your day. I'll send you the link to these things. And third thing, I'm noting videos, video of stack and PQ. Yeah. Okay, guys. Then see you.